tangents and normals are. So here in my, I'll just put an equation in here. Let's say y equals x cubed minus x, oops, I just need to get it down, minus x squared and plus x, and there we have an equation. Let's make it. So here I have a graph. Now you might remember before we looked at what a tangent to the graph was. So at any particular point on my, oops, let me put it right on the line. At any point on the line, I can have a tangent. So the tangent is the line that just touches at that point. So I'll get my ruler. So the tangent will look something like that. It just touches. Now, with your tangent, can anyone remember what did we say that tangent was? We also had another name for it. It was the
instant gradient.
Instant gradient. So that tangent line gives us the gradient right at that point, which should give us a clue to how we find the equation of it, because we know that equation of a line is y equals mx plus b. What is m? The gradient. Okay, so now that we know, using our differentiation, what the gradient is at a point, we can now use that to help us find what the equation of the tangent is. Keep that in mind, we'll come to the theory side in a minute. The normal though, at any point, the normal is a perpendicular line. So once again, it goes through the point on our graph, just like the tangent does, but this time it's perpendicular to it. Okay? Perpendicular to the tangent, yes. So your normal line goes through the point and is perpendicular to the tangent. So it cuts the graph. Let's just think about this. If it's perpendicular and we know the gradient, how do you find the gradient of a perpendicular line? Reciprocal, negative reciprocal, or we might remember m1 times m2 equals minus 1, which another way to do it in practice is do the reciprocal and change the sign. Excellent. Come back to our notes and let's see what it says. And it's going to say very similar things here. Just make it a little bit bigger. So the equation of a tangent at the point x1, y1. Step number 1, differentiate the given function to find the gradient function. Why do we need to differentiate it? We said it just before. To find the gradient. So when we differentiate our function, in other words, we're differentiating that graph, it gives us the gradient, which is the m, which we need to find the equation of a line. Okay, we then need to find the gradient of the tangent, okay, by substituting x into the gradient function. So we find the gradient function and then we substitute x in and it gives us the m. And then we're going to use the point gradient formula. Remember, this one is on your formula sheets. Okay? So that's readily available for you to find the equation of the tangent. So if you can come now to your notes. No, sorry, not the notes, the examples. Okay, it's just coming up. Come to the examples and let's do one. So here, 7.7. It says, find the equation of the tangent to the curve. Here's our curve at the points 2 and 9 over 2. First of all, let's find the gradient function, and to do that we differentiate. So, I'm going to say,
that's going to be 2.
Differentiate this with respect to x.
That's 2.
So this is 2, exactly, because when we have a coefficient and an x to the power of 1, it just becomes the coefficient. Okay, this one, well, let's just rewrite this. This is 2x plus x to the minus 1. Are we happy with that?
Yeah.
1 over x means x to the minus 1. When I differentiate this, what will the coefficient become? Minus 1, because I times 1 by minus 1. So now that needs to be a minus. And then what happens to the power? A minus 1, which becomes a minus 2. So x to the minus 2. Good. Or I could rewrite that and say 2 minus 1 over x squared. And I've got it. So I've done step 1. If you remember back to the notes, it said first differentiate it to find the gradient function. We have found the gradient function. Now I want to actually have a number. This isn't a number, it's got an x in it. I want to find actually a number that can help me find the gradient of my line. So this time I know that it's at point 2 and 9 over 2. So my x, 1 is 2 and my y, 1 is 9 over 2. So what I'm going to do is to find the gradient, I'm going to substitute 2 where I have x. Does that make sense? I'm just putting 2 in where there's x. So that should have been a minus. Minus 1 over 2 squared, which is 4. So my gradient then is going to be, well, we have 8 over 4 minus quarter, 7 over 4. We're okay with that? Okay. Now our point gradient formula. What's the point gradient formula? Do we remember it? Remember, you don't need to memorize it. You only need to be able to use it. It's on your formula sheet. So I'll do it over here. So y minus y1 equals mx minus x1. Remember that? We've used this before. So now we'll just substitute our values here. We've got y1, we've got x1, and we've got gradient. We've got everything to now make this work. So we have y minus 9 over 2 equals 7 over 4. X minus x1 is 2. Okay? Now, all we're going to do is just make it down into the general form, put everything on one side. So to do that, we have y minus 9 on 2 equals 7 over 4x minus, times that by 2, 7 on 2. Okay? Move everything to one side. So to do that, I'll do 0 equals 7 4x minus y. Now plus 9 on 2, so if I plus that, that will become plus 2 on 2, right? Which is just 1. So 0 equals 7 over 4x minus y plus 1. We don't like to have fractions when we have an equation of a line in general form. Well, so Michael, you reckon times by 4? If I times this side by 4, what do I get? Still just 0. Equals 7x minus 4y plus 4. And there's my equation. Okay, so there's 3 steps to these. So a question like this would be worth a few marks because it's not just straightforward. So whenever you are asked to find the equation to the tangent, first differentiate your function. Differentiate the function to find the gradient function. Once you've got the gradient function, substitute in your x value to find the gradient at that point. Then just use your point gradient formula to find the equation of the line.
I don't understand how you went from minus 7 over 2 to minus y plus 2 over 2.
Oh, okay. So what I did is I plussed 9 and 2 to both sides.
Yeah.
So plus it to this side, it gets rid of it. Plus it to this side. Minus 7 over 2 plus 9 over 2.
Oh, would be 2
It
over
would be
2.
2 over 2. Great question. Any other questions before we go on? Anything else?
Can you please
That work? Okay. to the normal. The normal is very similar, but this time the normal is going to be at right angles, or it's perpendicular. So that's why there's one extra step here. I'll just rub it out so we can read it. So, differentiate the given function to find the gradient function. Exactly the same as how to find the tangent. Find the gradient by substituting x1. So to find the gradient at that very point, you're just substituting the value of x. Now, this is the extra step. We now want to find the gradient of the normal, so we use the m1 times m2 equals minus 1, or simply take the reciprocal as Connor said and change the sign.
Yes, now my name's on public YouTube.
Oh, that's alright. Use the points. Now we're going to use the point x1, y1 and the gradient that we found in 3 and the point gradient formula. So, almost identical, it just has one extra step. Let's do one. Come back to our notes here, and let's do it. Step number 1 is to differentiate this. So, y dash, remember there's several ways of saying the gradient function. If I put a dash after it, that is one way of doing it. So y dash is, tell me what you think it would be.
3 times 2.
Which is?
6x.
So 6x, I agree, 6x.
Wait, so Miss, to differentiate, do you just times the power by the front number or something?
Yes, and then minus 1 from the power.
Okay.
So done step 1, we found the gradient function. But we haven't found the gradient at that point. We want to know it at the point where x equals 2. So to find that, I just put 2 into the gradient function. 6 times 2 is 12.
That's it.
Great, I've got that. Now, I actually don't have x1, y1 yet. x1, well, I do have x1 because x1 is 2, but what is y1? How do I find it? Didn't give me y this time.
It's 0. It's 0.
Well, what I do know is I have the equation, I can work it out. Put 2 into here, 2 squared is 4, 4 times 3 is 12.
Miss, why is the gradient 12?
Sorry?
Why is the gradient 12 again? Okay, substitute x in.
Oh, I substituted x in. So I differentiate to find the gradient function, and then I substitute x in to find the gradient at that point.
Yep.
So I've done that, and my gradient is 12, and I have my x1, y1. Okay, that, remember, is the gradient of the tangent, not the normal. How do I find the gradient of the normal?
Perpendicular,
So gradient, it's perpendicular, so gradient of normal
Would equal minus 12.
equals,
1 over.
m equals 1 over 12, and it's minus. Great, remember we take the reciprocal and we change the sign. So it's minus 1 over 12. Okay, now let's put everything into the point gradient formula and use that to find the equation of the line. So, gradient, I have the gradient. So we have y minus y1 equals m x minus x1. So, y minus y1 was 12 equals gradient minus 1 over 12. X, which is 2, oops, no, I meant just x, and then x1 is the 2. Okay, I have that. Expand out the brackets, y minus 12 equals minus 1 over 12x plus 2 over 12. I want to get rid of the 12. How do I get rid of the denominator of 12? Times everything by 12. Okay, I'm going to come up here and finish it off. So times everything by 12. Y times 12 is 12y minus 144 equals, times out by 12 is just minus x, times out by 12 is plus 2. Can you, sorry, can you
Oh my
that off.
Big
Yeah.
numbers.
You
All
can-
I've done is I've times everything by 12 to get rid of the denominator. So I'll do that again. Y times 12 is 12y. 12 times 12 is 144. This times 12 just gets to minus x. 2 over 12 times 12 is just
So
2.
the last one.
Okay, now I just need to get it in general form where I have everything on one side.
X
So
plus
plus
12y.
x
Plus 12y.
plus 12y.
Minus 148.
Now minus 2
146.
minus 6.
What are you doing?
Did you get that?
Yeah.
Fantastic. And there we have it.
Yes, I have a question. How do you get y1 equals 12?
Okay, good question. What I did is I substituted x equals 2 into just the equation,
Oh,
into the function. So 2 squared is 4, 4 times 2 is 5.
Okay.
Good question. So sometimes it will give you the point, so it will give you x from y1. If not, you just.
was it just a coincidence that the Y1
Yeah, that's
was
why I was
gradient?
confused.
Yeah.
Yeah, okay, the gradient and the y1 is the same, that is a coincidence.
I thought you put the gradient into the Y1 and I was like, what are you doing?
No, that one is just a very interesting coincidence.
Okay.
Okay. Well, I'm actually going to leave it there and let you practice finding this today, and we'll just
Cool.
leave it there with the theory and let you do some work for the rest of the